All right. So several years ago, College Board started adding what I call unnecessarily tricky units or unnecessarily tricky limits. I'm not sure why they got to be in their bonnet about it, but they did. And now I haven't seen any on the free response, but I imagine some of these have crept into the multiple choice. So if you have two functions for a limit that you're looking for, if one of them doesn't exist, you're going to have to look from the left and the right of whatever that composite is. So let's take a look at this. The graphs of f and g are shown in the figures above. Which of the following statements is false? So the limit as x approaches 1 of f of x is 0. True or false? That's true. Right? We don't care that the value of the function at 1 is 2. We only care what happens near x is 1. The limit as x approaches 2 of g of x does not exist. Well, we all agree with that because as we approach 2, the left and the right-hand limits do not agree with one another. Here's where it starts to get a little more interesting. The limit as x approaches 1 of f of x times g of x plus 1 does not exist. Now, for this, you got to go, well, wait a minute. As x approaches 1, f of x is going to approach 1, but g of x plus 1, as x approaches 1, is like g where we're approaching 2, and that doesn't exist. Just because one of these two doesn't exist, it doesn't mean this whole thing doesn't exist. You're going to have to look from the left and from the right. So if I do the limit as x approaches 1 from the left of f of x times g of x plus 1, as x approaches 1 from the left, f of x approaches 0. As x approaches 1 from the left, g of x plus 1 approaches 1, right? So that's 0. And then the limit as x approaches 1 from the right of f of x times g of x plus 1 as x approaches 1 from either side, f of x approaches 0. As x approaches 1 from the right of g of x plus 1, well, that's going to be like close to 2. That approaches negative 1. What is that?
0.
Also 0. This is false. This equals 0. So this is the false one. Let's real quickly double check by seeing, is D really true? The limit as x approaches 1 of f of x plus 1 times g of x. Well, f of x plus 1, I don't really know what that number is, but it's something less than negative 1, right? And as g approaches 1, it's going to be whatever that number is times 1 from either side, right? So this does exist because both of those individual limits exist. All right, let's go on to the next example. By the way, all of these examples I creatively acquired them from AP Classroom. They're all from there. So the graphs of function f and g are shown on the interval between 0 and 5. Let h be the function defined by h of x as g of f of x. Find the value of the limit as x approaches 3 of h of x, or explain why the limit doesn't exist. Use correct limit notation in your answer. All right. So as x approaches 3, what does f of x approach? It approaches 2, doesn't it? But notice, and this is the tricky bit for this one, it approaches 2, but it approaches 2 from above, meaning its value's bigger than 2. So you can't just do what people want to do on this when they're doing the limit as x approaches 3 of h of x. That's not necessarily going to be the limit as x approaches 2 of g of x. Although this approaches 2, it approaches 2 only from above, right? So we're only using values that are bigger than 2. The only way to make that equal would then go the limit as x approaches 3 of h of x is equal to the limit as x approaches 2 from the right of g of x. We approach 2 from the right on g of x, that's equal to 4. So you with me on that? It's tricky. And it's because on f, the limit as x approaches 3 of f of x is 2, but it's only positive values, or values of slightly larger than 2, right? They're all slightly bigger than 2. So we only need to approach here from the right, not from the right and the left. Guarantee you problems like this aren't in any textbook that's been published, probably before 2023. They just added it. I'm not sure, and again, I'm not sure why. I'm like, it's kind of interesting. Is it important? No. Interesting and important are two different things. I know lots of people that are important who aren't at all interesting. And I know some people who are interesting who aren't terribly, terribly important in the grand scheme of things. All right, let's take a look at this one. The table above gives values of the function f at selected values of x. Which of the following conclusions is supported by data in the table? Not necessarily what's true, but is supported by the data in the table. So as x goes to 4, so 4 is somewhere in here, does f of x go to 6? Well, let's look at from the left and the right. The limit as x approaches 4 from the left of f of x, what does that appear to be?
6.
It appears to be 6. So I'll squiggle it. I'll say it's about 6. But what about from the right?
7.
Yeah, maybe 7. So it's not that one. This one says the limit as x approaches 4 of f of x is 7. Well, from the right. And here we have the right one. The limit as x approaches 4 from the left of f of x is 6. And the limit as x approaches 4 from the right of f of x is 7. This one is correct. This one, they just reverse them. That one's not too bad. All right, let's take a look at this. The table above gives values of f at selected values of x. Which of the following conclusions is supported by the table? All right, that the limit as x approaches 6, which would be right in here someplace, is 0. Is that supported by the table? No. The limit as x approaches 6 of f of x is 6. No. The limit as x approaches 6 of f of x is 10. I don't know where they're getting these values from on that one. That's the, you're doing a serious test and one of the answer choices is Mickey Mouse. You're like, okay, we can throw that one out. The only thing left, limit as x approaches 6 of f of x doesn't exist. Because as we approach from the left and the right, do those seem to be getting closer and closer to the same number? No. All right, let g be a function that is increasing for x less than 1 and increasing for x greater than 1. Okay. If the limit as x approaches 1 of g of x is equal to 5, which of the following could represent the function g? Well, let's skip down and do the graph first. Is the function increasing for values less than 1? Values of x less than 1? Yeah. Is it increasing after that? Yeah. Does the limit as x approaches 1 of g of x equal 5? 1, 2, 3, 4, 5. Yep. Looks like it to me. That works. Let's do the table next. Is this increasing as we're moving from left to right? 25, 50, 100, 5,000, that's increasing. Let's see if these are increasing. Negative 5,000, negative 100, negative 50, negative 25, is that increasing? Yeah. But then this says the limit as x approaches 1 of g of x is 5. Now, g of 1 is 5. But we don't care what happens at 1. We only care what happens as we get close to 1. And are those getting close to 5? Nope. And let's look at this first one. And I'm going to go ahead and factor that expression. That's going to be x plus 4 times x minus 1 over x minus 1. Well, that's equal to x plus 4 as long as x is not equal to 1, right? Any other place, x minus 1 divided by x minus 1 is just 1. So, x plus 4, well, that's a line with a slope of 1. It's increasing all the time, so that gets the increasing part. As x gets close to 1, Does this get close to 5?
Yes.
Yes. Do we care about this 3?
No. Or, yeah.
We don't care what happens at 1, we only care what happens near 1. This could also represent G. In fact, this is the graph of that.
Yeah.
All right, any questions? All right, I've got a worksheet for you.